Technically speaking, I ain't talking vegan when I said that I've been eating, making money on the side, but I use it for the main.
All right. So let's get started here. So we're back with the path of learning how to become a Cisco VoIP engineer, right? We want to learn voice technology or telephony because that's a specialized skill and that's where the money is at. And, you know, it's a lot to learn, just like any other skill set you would learn. But once you get in it, you'll really see a lot of benefits. And again, just you guys learning, breaking into text, it's great to just learn about how things work in general. No need to actually go and be a Cisco voice engineer. You can just, you know, learn how voice technology works. So you may be able to translate it in a sense, or you just may have that extra knowledge in your memory bank to, you know, recall and help certain situations. So let's get started. Excuse me. Let me drink some water here. Excuse me. Okay, so let's see. I was going to do outbound calling since we already did IP phone boot up yesterday, but I think inbound calling is best. Just to recap, IP phone boot up was really just about connecting the phone to the network, right? So we are tasked with, let's say the company bought a company out, did like a merger and acquisition or something. And now, you know, we had a whole bunch of, let's just say 1,000 phones, IP phones, Cisco IP phones transferred over to this new site. And now the, you know, technicians plug them in and everything. And we as the administrators are making sure that that phone is accounted for and is now can get registered to our network. So we had to know a few things, do a couple configurations. Now our phone is up and working. It has a dial tone. And now let's talk about inbound calling, to where we now can receive calls, okay? Our phone is sitting there, we're at work minding our business, and our phone rings. How does that process happen? So we're gonna talk about those steps of how you actually get a phone call into your office phone, or into your phone period, right? Because this is kind of general. It kind of goes over, again, how audio travels, period, right? So I have the diagram over here, because we're going to go into, you know, a couple other things, but just to show you guys a high overview of what we're going to talk about. So we have an ANI, A-N-I. ANI means automatic number identifier. It is the caller ID, right, of the caller's phone. So whoever is making the call. So let's say, you know, you are going to make a call to someone. Your phone number is what we would call an ANI, an automatic number identifier, okay? Let's say that Karen decides to pick up the phone and they want to call to, you know, customer service. So Karen is ANI. Once she picks up, dial those numbers, her voice call will go to what we call a PSTN. It is our version of the internet. It is the telephone version of the internet. So it's nothing but a whole bunch of telecommunication companies like AT&T, T-Mobile, you know, all these service providers put together routing phone calls, okay? That's our cloud. Our cloud is called PSTN, Public Switch Telephone Network. We'll go more into it as we continue learning about protocols and such, but just know that the PSTN is like our internet, the, you know, audio's internet. So Karen's phone call goes through the internet, the telephone internet, and the telephone internet already knows where to route this call based off its digits and all this other stuff. So the telephone network is able to route the call now to our gateway. Okay, we have a voice gateway, which is a router, but a router with voice capabilities, right? It has a special type of card, and this card has a controller on it, and it has these special processors that what it does is when the call comes through to our gateway, it now has to translate from an audio signal, right, from an analog signal into a digital signal. Why do we want that to you know, convert? Is because digitally we're trying to, you know, we're trying to travel voice over internet. So we have to do that in a ones and zero type of way. Ones and zero is digital. Ones and zero means computer. It's not real. What is real, what is natural is analog. Analog is, natural sound. But ones and zeros is not. That's a computer. It's not natural. It's digital. So we have to translate audio, analog audio into digital audio. And we can do that by this router. This router has this special chip in it that does that. So us as the engineers, as the voice engineers, what we have to do is ensure that we have our dial peers. Our dial peers is just, a way to say, this is how we're going to utilize this call, utilize this audio signal. And we have to do what's called an ingress leg and an egress leg, two different dial peers. So ingress, you coming in to our network, ingress, you coming into our network, egress, you're going out of our network. But we have to set up these two dial peers. And as you can see, there's a few commands that we would have to put, like dial peer voice. We can give it an arbitrary number. 100 is just easier to put right here, but you may have to put it as 2000 or 201. It's arbitrary. It's whatever the scheming is in the company. And then you will put POTS, or in the other dial peer, we can put VoIP. POTS mean that it is a telephone pole that is bringing in audio. And then VoIP means that it is a virtual line of communication. There's no physical line. It's a virtual line, okay? A cloud-based line. So we have to make sure that we can configure these two dial peers so that these dial peers can help the router packetize, what we call packetize, which is, again, converting audio signal into digital signal. So now we have a phone call, we have audio voice, it's like my voice I'm speaking to you now. My voice is now digitized into ones and zeros. And that ones and zeros is going to go to what we call our CUCM, and it's our call manager, right? You'll see it kind of written different ways. CUCM, you may see just CM, or you may see call manager, or UC, Unified Communications. We have a different ways we can say it, but just know that it is our call manager, right? Our processor, our main processor, which we call a PBX. Okay, it's like our public exchange. So it's where all our phone calls are housed. This is where they go, and this is where they terminate. Okay, this is like our main wheelhouse, our controller. Now, once the router packetizes everything and makes everything digital into ones and zeros, which is our audio, it goes to our call manager, and our call manager now can signal our phone, and our phone, for us, because we're waiting on the phone call, we are called a DNIS, right? A DNIS is a dial number identification service, right? It's basically just saying that this is who we are going, this is who our caller ID is. Okay, so the Annie is someone who's making the call. A DNIS is someone who's receiving the call. So when we're troubleshooting, in our troubleshoot logs, they say Annie and DNIS. So you have to understand which one is having the issue, which one you need to troubleshoot. Okay, so back to the call manager. The call manager says, okay, we now have the audio call. We now have the number that you dialed. Let's see, can you dial this number? Do this number belong to us? And if it belongs to us, our call manager will send it to us and say, hey, you have a phone call. And then you take it off, you'll take it off hook, which means you pick up the phone and you say hello, you can hear audio. And now the voice signal will traverse from the voice gateway to the L2 switch and to your phone. Right? It'll actually go through here. The only time that we need to signal from the gateway to call manager, only time we need to use that, because we've done with it. Call control was good, meaning that this number belongs to, in this company, and you can call this company. So now that everything was checked, the only time you need to go to call manager, the only time we need any type of communication with it is if we're using things such as music on hold, when you're, listening to hold music, or if you're trying to conference someone in, maybe you're trying to do a three-way call, or you're trying to transfer a call, right? You'll need call manager for that. But if it's just you and if you and the Annie is just talking back and forth, you only need, the voice gateway and your phone, right? So that's kind of that in a like high level explanation. Again, as the engineer, you need to know this whole process and you need to know it in depth, right? So we already know that what Annie is. Annie is the calling party. Annie goes to the PSTN. We should know what a TN is, which is our telephone collection of telephone service, right? Those are our actual poles. Okay, so let's go into the gateway, because the PSTN, when it hits is our gateway, and it hits it through telephone poles. Again, those telephone poles are what we call PRIs. Okay, they are primary rate interfaces. Now, these PRIs are physical cables. Okay, like they are those big old cables outside that you see going from pole to pole. And most of the time they're in the ground. Okay, so a lot of times you don't even see the poles. So those poles are owned by service providers, which could be AT&T, T-Mobile, and those are like low people. You have other companies like Lumen or Bandwidth that, own majority of these telephone poles. And you'll see that as you get into the field, you'll have to talk to these vendors to say, hey, I would like, well, you probably wouldn't, maybe the manager would, but you would be in the room to where they're buying telephone service from this service provider. Okay. And they will give you what's called PRI lines. Now, this PRI lines, again, will give you service from your network to the rest of the world. Okay. It's outside of your network. So you wouldn't have a PRI line in your network. Okay. So this is more towards, again, the outside world. Now, your service provider will give you 3 settings. You have to put these settings in. Again, they tell you what to put in. You as the engineer needs to know that it's formatted correctly. So they'll give you a few things. I highlighted them. Excuse me. We're not going to go in because that would, open up a whole nother can. But just know that they have to give you some settings in order to even make this telephone pole line, aka PRI line, work. Okay. Now, in voice, again, and just engineering, as being Cisco engineers, we work with the whole world. So we need to know what we use as in American use, and then we need to know what the world uses as well. So, because we're different, we don't do what the rest of the world does. So, as let's say we work for a big company like T-Mobile or Vanguard or something, we have to work on networks that are not only American based, but maybe they have a site in Asia or a site in Europe or Australia or something. Okay, and they're saying, hey, we need to troubleshoot why these calls are not coming in the Europe site. And then you're looking at it. You can't look at it with the same eyes as you'll look at it as an American site. So the PRI comes in 2 types. They have a T1 and an E1. E1 is used for Europe and Australia. So it's different types of signaling protocols. T1, which is North America and Asia, you'll see that a lot more often because, they usually higher within. So you probably won't work too much outside of North America, but it's most common because, again, we're in America. So again, that has its own signaling protocols, or at least the way that it handles these calls. And the big thing is the total number of channels. The channels are literal lines of audio communication. How many channels can audio traverse, across? The E1, they have 32 channels. T1, they have 24 channels. Okay. So again, we're not going to get too deep in it, but you definitely need to know that, we have PRI lines, which are telephone poles. Those telephone poles are governed 2 different ways, a T1 way or E1 way, as far as PRIs. And, T1 is North America. We'll always use that. E1 is the rest of the states, the rest of the continents. Okay. So our PRI, our line is to the PSTN. It comes into our gateway through our own PRI line that we manage. And as it comes to it, it stops at our gateway. See, I have the little stop sign here. So it's saying stop. What do we do with this audio call, right? Because this is just the audio call because it came through telephone poles. So it's not riding with the internet. It's just regular telephone, Alexander Graham Bell type, you know, technology, very analog. So our voice gateway, you know, we have we want VoIP. We have, integrated more technology. We're in 2023. So what we want is VoIP calls, AKA voice over IP calls. So now we need our voice gateway, excuse me, to do something which is packetize, AKA digitize our analog audio into ones and zeros. Now, our only way to do that is to have a router that has these capabilities. And these capabilities are through a WAN card, or voice WAN card, which you see right here. It's VWIC, a voice WAN interface card. And there are different type of models, but this model right here is a 1MFT, you can see right here. And it's literally just slides right into the router, okay? Some of you guys maybe know about taking apart a computer or building something on the motherboard. You kind of can know, like if you was to put like a VG card or something, or even like a video graphics card, it's the same way. You just slide this little module in right on the motherboard of the router and, screw these little screws so they stay tight. And then you'll plug your Ethernet cable right through here, right? So now your voice gateway is up and loaded. There are two different types, we're not going to go in, but they're literally here to make sure that the audio comes in and the audio can now, see what's going on in the network to figure out, let's go ahead and packetize, right? So let's go ahead into our ingress leg and our egress leg. So it's packetizing, it comes into our egress leg, right? It's important to know that it's the ingress leg, packetize egress leg, right? It's happened 5 seconds. And why this happens is because the ingress leg is saying, hey, I need to know, do you belong in my, are you where you need to be? Can you even hit my voice gateway? And again, how do we do that? With dial pairs. The dial pair is saying, okay, this line is up, so we can't accept calls. We're going to accept calls, putting incoming call number. And that's, again, saying that we can accept it. And then direct inward dial, we're making sure that there's no fraud. There's no toll fraud. People are not, we're not paying for calls that are like spam calls, you could say. And that's because that makes our bill go higher because we're paying for each of the bandwidth. So if we have a lot of calls that are fraud, then we're paying out of our pocket and not utilizing the service properly. So we have to make sure that, fraud calls, spam calls, whatever you want to call it, it's not, no one's riding off of our bandwidth, you can say. Mm-hmm. So we have to put these things in to ensure that, hey, this is a legitimate call. Okay. And it's really these 3 things. It will have some more configs that you would have to put, but these are like the basic, like you have to put direct inward dial, incoming call number, and voice, dial pair voice, right? Whatever is POTS since we're dealing with PRs, we have to put POTS. Okay. Again, this number is arbitrary. It's just here to put a value, but it could be anything that's within your company. Okay. So now the number is actually a true number. It's not a fraud number. It's not riding on our bandwidth. Now that we know that that's true, we can go ahead and packetize it. Now that same motherboard on the voice gateway has these chips right here, DSPs, okay? Digital signal processors. These are these little chips. They're also on this module right here, but these chips are what actually does the packetization, right? They're on the little module, and they're also on the voice gateway, the actual motherboard. Okay, so they do the actual technology of turning your analog into digital, into the ones and zeros. Okay, now we have these DSPs, again, in a module that we can connect to. We can keep putting them, we can add more, take away DSPs. And then there are actually some that's based in the router. Okay, why would we add more of these DSPs? Because again, they're helping us convert analog stuff into digital. So not only just, regular basic one-on-one phone calls, but what about music on hold? What about, like an annunciator, to where you're like, hey, press 1 for so-and-so, or we're not here, these hours are closed. That all needs to be translated from an analog sense into ones and zeros because it's traveling over the internet. So how does that do that? These little guys right here, these DSPs. Will you work on these? Not really, as far as physical, but you still need to know about them so you know how many resources you need, how many DSP resources you need to make sure that in the network, they're not saying that, we can't do conference bridges. We can only do like 6 people on a call. And what if it's 12 CEOs, So that's a problem. I'm going to say all 12 of us should be able to be in the call. Why only 6 of us? Well, you need to get more DSPs and install them in a router. And that's usually something that, you get to when you get to being like an architect or you work with the architects. I've worked with architects. I've never been like, a job as an architect, but I work closely with them. So I've been able to actually, touch the DSPs and install them. And we're installing them with the PBDM. These, again, are the modules. They're the actual, again, modules that have the DSPs on them. So again, there's 2 different types, and we use them for different reasons. And again, we can upgrade them, downgrade them, however we need. So now these little guys, they went ahead, analog into digital. Now we can actually go to our egress leg. And the egress leg is saying, okay, let's look at this number and let's see where this number would go in our system. Okay, so the egress leg is saying, okay, we'll take a VoIP call and let's take a look at the pattern. Does the pattern match? Because if you see, I don't know if you guys probably realize that when you're in a job, maybe you got an office job, maybe you work for State Farm or something, you have your office number, just like your colleague's number and everyone probably on that floor or even in the whole company, they all have the same area code and probably the same area code with the same, next 3 digits. And that's because what companies do is they buy a full list of phone numbers and they say, these are our phone numbers. Our phone numbers are 713-365. After that, it's all different, right? But that's what our phone numbers start with. So we have every number that starts with 713-365-0000 all the way to 99999, right? That's probably like, I don't know, let's just say 1,000 numbers, right? So they buy those 1,000 numbers and they allocate that into the network. So now when a phone call comes in, an inbound call to say that they want to call somebody in the office, we already have a destination pattern set that say that if you don't start with these 6 numbers, you got the wrong area. So we're going to deny it, period, because that's not in our system and we don't need to even use any more resources to process this call because our phone numbers in this network only start with XYZ. And in this case, in this little example, it's 858-5555, right? And then everything else, as long as these 6 numbers match, then cool, we can continue letting you go. All right. So once that's check marked, let's say that that's a good number. It does belong to our company. We have a couple protocols that we have, but the main ones is session target. Session target means that what I have to do is I have to build a visible line to your call processor, AKA your PBX, your public exchange branch. Now, I would suggest you guys kind of do a little back research on public exchange branches. I did like this blog on it, on just how it advanced, because how telephone calls started. It started with literally people plugging in calls to another. So you would call the operator, hey, I would like, St. Charles at the NASA Center. And then they would literally say, hold on, go to like a switchboard, plug in your line to St. Charles line or to a line that can get to St. Charles. And it would just go like that, right? But technology has advanced so much to now we don't even need that. We have something that's not even physical, it's virtual. It's a virtual server that processes these calls that goes from one end to the next, So that job has been automated. So now what we're doing is we're ensuring that we have a virtual line that's connected to that cloud-based call processor, right? Which is called our call manager. Now, this cloud-based call processor, again, we have to build a virtual line. Now, the line doesn't go far from the router because, again, this is what this command says. This command says build a virtual line. So we have to create another line from the call manager to meet this line, right? And that is going to be our SIP trunk. Our SIP trunk is a virtual line to our gateway. It is a virtual line of communication. It's like from CCNA, you can think of like a sub interface or something, right? We're creating not a physical cable line. There's no Ethernet. There's nothing physical. It's all cloud-based. And this cloud-based line goes from the router to our server. Now we have to build it on both ends. So on the router, we put session target IPv4, which is the IP address of our call manager. And then on the other side, which is our call manager, we have to go into our SIP trunk configurations and actually build the other half, okay? Now, before we even go into that, the rest of these commands, voice class codec, we talked about codecs. That's, we're going to compress the audio and then decompress the audio so we don't use a lot of bandwidth. So we're giving them a list of codecs to use, which we learned one will be G711, another one will be G729. You should kind of, know these codecs. DTMF relay, that is the dial tone. It's dial tone multi-frequency relay. That's basically the deep, 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 the 1, 2, 3, 4, 5, that's actually, those tones actually mean something. They're not just there for your enjoyment of music. They're actually like Morse code, and they're, dial tone negotiations. And we have to ensure that we take those dial tones, because if we're telling you to press 1 for sales, we want to actually know that 1 means 1 in your language. Okay. And then we have no VAD, and VAD is just, it's a technology that it's an automatic technology with voice that if you hear like dead silent, the call will just drop. The call will think that, oh, you probably hung up and just dropped. So to mitigate that, to make sure that don't happen, because people like to have awkward mutes and silences and we don't hear a background or anything, we have to put no VAD so it doesn't automatically drop the call. And that's just it's like technology that's already embedded, I think, in the gateway or something in that sort. So we just, put no VAD to ensure it. So again, all our configurations have been checked and hit on the router. It made this halfway SIP trunk to our call manager, because our call is still there. Our call is like, hey, I need to speak to customer service. Okay, Karen is waiting. Now this whole thing is happening within seconds. So, you can think of when Karen calls, she rings probably like one time and it picks up, hello, you have reached AT&T or whatever, I don't know, but she's calling, her call is still there. Now let's go to the call manager, right? Where's the call manager? Let's go to the call manager and see where we're going to build the other half of the SIP trunk, because the voice gateway said, here, this is the path to my call manager. It's this IP address, go as far as you can. And then, it needs another leg to say, to meet with it, which is the call manager. And then the call manager, remember I talked about, we are in the GUI, we're in a graphic user interface of it. So we go to a website, and the website, we go to it in a form of an IP address. We go to, most of the time it's like 10.1.8.1, or 10.1.1.1, and it's internal address. So of course, every company can use it. So that's usually the scheme that I've seen in all these companies. So you will probably go to an address like that, 10.1.1.1, and it will pull up your call manager. You will sign in with your username and your password, and then it would bring you to the dashboard of call manager. And you would click through some things, but you would end up on trunk configuration. And this is nice and pretty. You can do drop downs and configure your trunk beautifully. Now for this specific task, which is inbound calling, to accept inbound calling, all you have to worry about is your inbound call section right here, right? So we have inbound calls. All we care about is the significant digits. It's all different depending on the company. So you can say all digits. Remember, the company bought these phone numbers. So we're saying that, do you care about certain digits? And just like what we showed you in this example of dial, in this configuration, the destination pattern needs to be 858-555, and then the next 4 doesn't matter. So instead of saying all significant digits, we'll say 4. We have 4 significant digits that we need, that we care about. Forget the 858-555, because we know that that's already been check marked. We just care about the last 4. Is the last 4 there? So we say, yeah. And then we have to make sure that we have a destination IP, which is the IP to the gateway, because the gateway had the IP to the call manager. So now the call manager needs the IP to the gateway. So we put that in somewhere down here. I don't think I've showed it, but somewhere underneath. And then you have an inbound CSS, which we'll talk a little bit more, but a CSS is just like a call control. It's like saying, can you call this number or you cannot call this number? For example, you're probably at a job and you are a customer service agent and you realize that you can't make as many phone calls or you can't place out calls, but your manager can place out calls. That's something like a call control. That's something like a CSS. Right. So, employees cannot make outbound calls. They can receive it. Managers can make outbound calls, but only to certain people. And if you think about it, you'll probably have like the CEO or C-level folks making calls to anybody. Like they probably can call Pizza Hut, but maybe, the employee cannot or the manager cannot. Right. So again, it's call control. Right. So again, we made sure that we built the other half of the of the SIP trunk in the call manager. And now the call is able to, go through. And what the call is going to through is call manager is going to say, okay, this call is good to go. Let's go ahead and send a ring request to DNIS, right? Which is to us, the one that's receiving the call. So it's going to say, hey, we have a phone call for you. That's the ring, 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 put your ringtone on. And that's whatever it's going to, it's going to display. And then you're going to pick it up. And we call that off hook. You're going to take the phone off hook and you're going to say, hello, whatever, whether your customer service, whether that was your direct line, or whether that's your cell phone. The kind of all works the same and all the same way. So you're going to pick it up. You're going to say hello. And the voice phone call, the voice of the call now is traversing from the router because it held that router that whole time as we was going through that. So now it's on the router. It can release from the router and go down to our L2 switch and now to our phone. And we're just talking back and forth. Now we have to do anything outside that. Let's say we want to say, oh, let me get my manager. I'm going to patch you over to my manager, or I'm going to patch you over to tier 2, or, whatever. Let me put somebody on this phone or transfer you. I'm going to use a media resource, which uses those DSPs, which can come from call manager or the voice gateway, but we're going to use call manager. We're going to use those resources. And those resources are going to help conference the call, transfer the call, put the call on hold for, I don't know, music on hold. Like we have enunciator right here. So it's like, maybe it's an after hour call. You have reached us after 5 o'clock. These are our hours. Please leave a message, whatever the case may be, So it's a whole bunch of resources that we configure on this call processing node on the server that the phone can utilize as it goes through various stages of a phone call. Okay. Now we, again, have to understand how this all works. And if we to troubleshoot it and know how to troubleshoot it, basically. And that's how, again, we know, if we know how it works, we know how to troubleshoot it. So it can be as simple as, hey, when I try to transfer to tier 2, it never transfers. It just hangs up on the customer. Like every time I try to transfer someone, they hang up. You've probably been in that situation, whether the customer or you're the actual agent that's happening with. Then that could be an issue with media resources. That could be an issue with, us not configuring something or having the certain tick marks or something going on in this process is not right. And since we know the whole process of how an inbound call goes and stuff, then we know exactly where to troubleshoot. We know, okay, if you can't transfer calls, that's something with media resources, right? There's 2 types of media resources right here, hardware and software. Hardware lives on the gateway. Software lives on call manager. So you're thinking, okay, what type of media resource is the issue? So they're trying to transfer. That's something like conference. Okay, cool. So we know that can both be hardware and it can be software. So now we know that conferences deals with codecs. As you can see, it says dealing with codecs, dealing with G711, which is a codec. So now we need to figure out, maybe some codecs are not matching. Maybe the codecs are wrong. Maybe I should look and see what's going on with that. That now you chop down your troubleshooting through days if you didn't know any of this, right? Weeks probably, right? And that's really what keeps you in jobs. It's not about, oh, I have all this knowledge, or I've been to school, I have all this experience. It's really about, do you know how to troubleshoot? Do you know how to resolve issues? So if I have an issue with, bad quality, or they're not able to hear dial tone or something in that sort, you should kind of be able to, paint a picture like, okay, well, if they're not able to do this, and you're looking at the flow of a call flow, you can think maybe it's a dial peer. Maybe it's a resource on the gateway. Is the L2 switch even there? Like, what's going on with the data on the data network? It's just, again, so many things. Maybe it's the call control. Maybe the inbound CSS is wrong because it's not getting to the user, and they're wondering why they can't receive calls. Maybe they have the wrong call control. Like, that happens. You can literally be in a wrong group because people change things around. There's sometimes tier 1 who will go into the call manager and do things that they're not supposed to do. Or maybe there's a tier 2, it's just inexperienced, like you on your first job. You're probably on your first job and mess a lot of stuff up. And then somebody will come in and be like, well, what the hell was they doing? But again, that's just us learning. That's just, hey, you will be the one to mess things up and you will be the one to fix them. But you need to strive on fixing problems. Okay. That's how you get jobs, and that's how you keep jobs. Now, that's it. That's really all of inbound calling. The caller calls in, go through our PSTN, hits our gateway. Our gateway starts to do a whole bunch of tech stuff, turning things from analog to digital. It goes to our call manager. Our call manager says, hey, this phone belongs to us. This call belongs to us. We know who it belongs to. It goes to this person or this department, and it goes to that department and starts doing what it needs to do between call manager or between the gateway. Okay. Again, with voice, it's very specialized. That's all I care about. That's all I take tickets on. I don't care about anything else. If you can't get to the internet, that's not my issue. My issue is, can you make and receive phone calls? That's it. That's all I care about. If the system don't work, can you make and receive phone calls? Like, those, the only problems I care about is the only tickets. So it's very specialized. However, and when you are in a specialized skill set, you have to go really deep. So we talked about a lot of things like dial peers. You should know what a dial peer is, the different ways to configure dial peers. You should know why a dial peer is even here. Why do we have to have 2 different dial peers, right? Going deeper and more, you need to know the whole commands, destination pattern. How many different destination patterns are there? What's the different combinations? What can we do and can't do? Do we have to have these dots right here? Yes, we do. We have to have the number of significant digits of dots right here. So if you have something that's off, or if you're thinking that you're pressing 4 dots and you're not, it's going to mess up the call flow. It's simple things like that. Just almost like if you're coding, simple like curly bracket or semicolon can throw off the whole code. And it's the same thing here. So you kind of, again, we're specialized. So we have to be very meticulous to detail. And sometimes we're not, and it's okay. You learn. And as you learn, you realize that all of this is the same. It's all the same stuff. The only thing is different is the way the companies configure things differently. As far as some may have, different things in their ingress leg, their POTS dial peer. They may have more, they may have less. Egress, they may have more, they may have less. But I mean, again, it's all still the same, right? There are a whole bunch of different codecs. So now you have to learn as a voice engineer, different codecs, different algorithms that decompress and compressed audio. You're really turning it to someone that basically, learning like audio engineering, like you're learning about, the different ways that sound travel, the different frequencies of sound. Right. And then you're learning how that frequency and how that sound is translated and converted into technology, which is 1s and 0s. And then you're learning how to take those 1s and 0s, that technology, and ensure that, folks can make and receive phone calls. And it's very deep, but again, it's very high level because a lot of people, a lot of architects, a lot of engineers don't know this deep. There's a lot of people that's 20 years deep in their like a voice engineer, and they don't know this information. I created this diagram myself through my own knowledge of, me being taught. So when I show this to people that I work with or that been in the game for 15, 20 years, they're like, damn, I didn't even know that. And I'm like, how? How? You've been in this for 20 years. Like, this is your bread and butter. Why don't you know this? Why do I have to, someone who's been in this for, 2+ years, I have to explain this to you now. So that you should put that into perspective, right? But yeah, that's really it.